we will learn in this session about climate change and how it can lead to economic inequality and violence. And talking about this subject, I think we are so lucky to have our speaker, Dr. Solomon Cheung, the Chancellor, Associate Professor, Public Policy, and Director of the Global Policy Laboratory, UC Berkeley. His recent work uncovered the effect of global temperature on global economic growth and inequality. In fact, the most accurate and efficient way to learn the future, to learn about what to expect in the future if the global climate warms, is to use the data science and mathematical models. Dr. Hsiang published recently a study in Science Journal in June 2017 under the name Climate Change Damages US Economy, Increases Inequality. The study highlighted the fact that unmitigated climate change will make the United States poorer and more unequal. Also, the study may settle the debate over whether climate change will help or hurt the US economy. Now I will leave the floor and I will enjoy with you the presentation of Dr. Solomon. Thank you.
This is the right one. Great, thank you for having me. My name is Solomon Cheung. I'm at University of California, Berkeley, where I run the Global Policy Laboratory out of the Goldman School of Public Policy. And every day when I come into work, I ask myself the question whether or not we're using the world's resources in a way that maximizes opportunities for the most people around the world. Today, we live in a world of tremendous economic opportunity and technological innovation, where we're building towers almost a kilometer high, and we're able to autonomously land rockets on floating rafts out in the middle of the ocean. And at the same time, though, there's millions of children around the world growing up with distended bellies because they're full of parasites. They don't have access to clean sanitation. And there are about 1 billion people around the world working as quickly as they can to improve the living standards for their families through economic development, sort of pushing the world's systems as far as we can push them. There's so much strain on natural resources at this point that regions like this part of the Amazon, we can see the degradation from space. And in fact, the fingerprint of humanity right now is so profound that, which is planet Earth from the edge of the solar system, if there were an alien astronomer doing spectroscopy on our atmosphere, they would see the rise of humankind in their data. So right now, what we're trying to do is make decisions about how much to invest in our global energy system, making a choice about what roads we want to be going down. My job is to help inform decision makers about what might lie ahead on these different trajectories. Do we want to travel down a business as usual path? Do we want to spend more money to achieve one of those other trajectories? Or are they not worth the investment? So how do we make these types of decisions? Well, I teach at the policy school, and I think it's helpful to make the point that throughout human history, there have been major revolutions in the technology of governance. So whether it's the idea that maybe we ought to write down what our laws are so that we can agree on them, maybe it's this notion that people should be treated equally, or that everybody should be allowed to vote. We are now at a moment where there's a fundamental technological revolution unfolding, which is the use of data and analytics to help design superior policy decisions. And that's the type of tools that we apply to the question I laid out in the beginning of how do we manage the global climate in this incredible age. So the fundamental scientific problem that me and the folks in my laboratory ask is how should we be investing? How much is it worth to invest in mitigating certain types of climate change? And the reason to ask that question is because if we move resources towards mitigating climate change, we necessarily must be moving them away from other types of investments. But there are fire departments and nursery schools and roads that need investment as well today. So there are real trade-offs. It's not just that we can throw everything at the climate problem. So to sort of think through what it's worth, it really comes down to distinguishing between these sort of two different scientific hypotheses, right? It's stylized here. Either the climate matters a lot for human society, in which case we should throw more money at it, or it matters much less, in which case we should be spending on other things, like putting more money towards certain types of technological innovation. And this question has been around for centuries, right? Many famous thinkers have asked, what is the role of the climate in determining society's fates? But it's a really hard scientific problem because the climate itself is a fundamentally very high-dimensional object. There's lots and lots of things going on. At the same time, human society is very complicated as well. And so the two are interlinked at many, many, many different points, and trying to understand what's going on can get quite complicated. In particular, there are many confounding factors that are really critical and to think about very carefully, because if you're not careful, you draw many, many incorrect inferences, I think as many thinkers have for the last few centuries. So what is the approach that our teams tend to take? Well, the ideal experiment, which I think helps frame the problem, is to imagine you have two worlds, you heat up one, you don't touch the other, and then you observe what the difference is, right, between the treatment and the control. That's kind of the science fair version of the ideal experiment. The IRB does not approve that one, and so instead, what we do is we think about a quasi-experiment that sort of emulates that ideal experiment, but actually happened historically in the real world, okay? So the first step is to go back in time and try to reconstruct what the historical exposure of different societies has been, and then to look at any sort of abrupt change in the environment, or maybe a gradual change in the environment, and ask how that affects the society, because it's the same society being exposed to both the treatment condition and the control condition, just at different moments in time. So that's the overarching approach that we take. And what I'd like to do is help walk you through several of our studies to get a sense of the kinds of techniques, methods, and then findings, and also policy prescriptions that emerge from this type of research. So folks in the United States don't need to be convinced that hurricanes are important. In particular, Typhoon Haiyan is one of the most record-setting storms, and when it occurred in the Philippines, you saw headlines like this, and we're seeing many headlines of this flavor in the United States after the last hurricane season. How do societies recover from one of these events? And actually, my colleagues and I have been thinking about this for several years now, so we actually know something that is being used in policy today. Just to give you a sense of how we uncover these types of relationships, we built a model. Here we call it we built a model of a hurricane, and we simulate historical hurricane events by rebuilding them from scratch. So here you see Super Typhoon Joan traversing the northern parts of the Philippines back in 1970. And what we do is we record what individuals on the ground would have experienced as these storms pass overhead. We then reconstruct all the storms that occur around the world in the historical record. So most people don't realize it, but there's roughly 100 tropical cyclones on planet Earth every single year. We reconstruct all of those in each year, and then we do it again and again for different years to rebuild an inventory, a database of every person's exposure to every tropical cyclone on the planet that we have in the scientific record. Then we can ask questions by linking it to economic data. So in this case, we went to the Philippines and we look at household level interviews where they go out and ask tens of thousands of households very detailed questions about how they make economic decisions and to also examine what type of assets they have. And so for example, what you see here is a graph that shows the probability a household is conspicuously missing strong walls to their house. Okay, that means they might have weaker walls of some other types of variety, as in relationship to the intensity of the wind that the household was exposed to in the previous year. Okay, so getting hit by a storm in the prior year increases the chance that these households are missing their walls. Now we can repeat that exercise using a variety of other types of large household assets. And what we see is that households have a lower likelihood of having a toilet, a television, access to electricity, a refrigerator, based on being hit by a storm in the previous year. Now maybe that's not too surprising, because these things are being destroyed in the storms. And one thing that we actually find that's somewhat reassuring, I don't have enough hands for this, what we find reassuring is that if you look on the left panel, we don't see any relationship between exposure and whether or not you own a car, right? And that kind of actually makes sense, because if you hear about 6 hours out that a storm is coming, you can drive your car up a hill to safety, but it's much harder to move your refrigerator, right? Now these large-scale destruction of assets lead to localized economic depressions that change household spending patterns. So on the right, what you see are changes in how much families are spending on different types of food. So you see, for example, in years when they were exposed to a stronger storm, they dramatically reduced their spending on nutritious foods like meat, fruit, dairy, and eggs. That leads to real health implications for these households. So we've taken different data, ask mothers about the entire history of children that they've given birth to and whether or not those children survive to adulthood. What we see is that these children are facing an economic environment in which resources and investment in nutritious foods are more scarce. And so we see mortality rates, in particular of female infant children in this community, rising dramatically in the months after individual storms. And in fact, we know that the date at which these individual children are being born, so the dashed line here shows you the date a child is born relative to a typhoon for all births that eventually result in infant mortality. So what you see is there's a big jump that occurs the month after a typhoon. So being born into a household that was just exposed to a massive storm, that's the worst place to be. But we also see that the rate of those births continue to increase up to 2 years after the storm. So roughly half of these children that are dying after the storm were not even conceived at the time that the typhoon struck their community. They're being born into an economic environment where they're competing for resources. We actually see that female infants are twice as likely to die after a storm if they're born into a family where they have an older sibling, presumably because they're competing for resources. And their risk of mortality after the storm doubles again if that older sibling is a male rather than a female. So these types of research allow us to calculate what we think are the actual costs of these storms as they strike these different communities in the Philippines, just as one example. So on the left are 2 bar graphs showing you what you might see in the newspaper as the overall economic damage from these storms, as well as the official tallies of mortality during typhoons in this period. On the right are the bars that we compute to be the overall economic burden of the same set of hurricanes and the overall mortality just among female infant children. Okay, so this work has highlighted for the government that roughly 12% of overall infant mortality in the Philippine region can be traced back to the very intense typhoon environment that the households inhabit. We've taken this type of approach and we apply it not just at these detailed household scales, but also at the scales of entire countries. So in macroeconomics, there have been many theories asking what is the effect that disasters play in economic growth. We care a lot about economic growth. It's what brings jobs and prosperity to households. And the debate, if you go to any sort of United Nations document or IPCC report or a World Bank report, this type of graph shows up over and over, where there's sort of 4 different hypotheses, we've given stylized names here, describing what might happen to an economy when a disaster strikes. So one hypothesis, you see that the economy is sort of growing along the dashed line, the storm hits, and one of 4 things might happen. One idea is this notion of creative destruction, that the storms, that disasters might cause people to do all sorts of things they wouldn't normally do, and that helps the communities innovate and do things better. So for example, maybe me and my neighbor both go and clear a tree off of our lawn together, and we start talking and we realize that our businesses could start engaging in some sort of collaboration that we didn't realize before, okay? So some disturbance to habitual habit or routine might be a productive thing. There's also this hypothesis that maybe we can build back better, right? You hear every politician after a storm saying we are going to build back better. A storm, like an event occurs, maybe we're going to suffer for a little while, but then we're going to pedal really hard and things will be better than they were before, okay? And so we end up on a better trajectory. And there's actually some economic theory that might suggest that that's real. So we know, for example, that people don't replace assets at the right rate that they ought to. So for example, I had a phone one time and it was driving me crazy. There were so many things I couldn't do with it. And I should have replaced it, but I didn't actually replace it until I dropped it and broke the screen. Then I got a new phone and I was much more efficient, right? And so it's this idea that maybe there's a lot of infrastructure, a lot of buildings that are hanging out in these cities, these communities, and they don't get replaced, but when a storm comes through, they get upgraded and suddenly things are more productive. Then there's this theory that we have a recovery to the trend. Maybe we'll eventually just catch up to the path we were on before, and that's actually has been historically economists' favored theory. And then the last theory, this one that says no recovery, what you see is the economy takes a hit, it declines, it eventually goes back to growing again, but there's never any rapid acceleration, so you never catch back up to that initial trend that you were on. You're just permanently poorer for the rest of history, okay? So people have debated these theories for a long time. We looked at over 6,000 historical storms that struck many hundreds of countries, and when we look at the data, this is what we see. So when you look around the world, and you look at economic performance after a cyclone strikes, you see that for the 15 years after the storm, economic growth slows down, and eventually it goes back to the same trend line it was on, but it never catches up. So we are actually in this no recovery world, at least as far as we can look 20 years out. This turns out to be something that is not just a feature of poor countries or small island states. So on the left, we break up the world into rich countries and poor countries, and they turn out to behave exactly the same when they get hit by a hurricane. You can look at small island developing states and everyone else. In the middle panel, you see pretty much the same behavior. And on the right panel, we actually break up the world. We look at North America, Asia, Oceania separately. Wherever we go around the world, we see something that looks like a fundamental relationship between how human societies are interfacing with their environment. Now, one can ask, what does this mean in the long term, right? We don't actually just get one hurricane. What we get are societies that are constantly exposed to hurricane after hurricane, year after year. And so we developed this idea that we call sandcastle depreciation. So depreciating an asset is something when it degrades. And you can imagine a world in which you take a bunch of children, you go to the beach, and you scatter them along the beach, and they all day are working to build sandcastles. Okay? But some are going to be near where the waves are coming in. Some are going to be further up. And if the children are all working on this all day, by the end of the day, you're going to see a gradient in how big the sandcastles are. Because the children who are inland are going to have these really huge sandcastles, and the ones that keep getting stuff knocked down by the beach, by the waves, they're going to constantly be struggling to build. And so you can actually compute what would be the sandcastle depreciation rate that different countries around the world experience based on the climatological exposure to hurricanes that they face. So just as an example, here on the left, you see the climatology, the long-run climate of how intense the cyclone environment is for different countries. You see, for example, that the Philippines is right on the edge of that big red blob. Okay? It's one of the most intense environments on the planet. And on the right is a graph of the long-run growth rate of these different countries plotted against what would be the predicted sandcastle depreciation rate if we were to base the calculation on the numbers I showed you in the very first set of results from the Philippines on how quickly household assets are destroyed. And so what you see are the countries that have much lower growth are the same sort of countries you might expect to have lower growth because they're located in the regions where they're getting repeatedly hammered by these storms, destroying assets. And when we compute what happens if we turn up the volume on hurricanes around the planet, the way the scientific literature suggests storms might intensify, which means, importantly, that they actually de-intensify in some parts of the world, in the Indian Ocean, the overall net effect, we estimate, is that the value to society today is on the scale of about $10 trillion. Okay? So that's what we should be willing to invest at this moment to avoid the trajectory, the high emissions trajectory, in which the cyclone environment becomes more intense. Now, what does that mean, in the United States, for example? How are we doing? What does that mean for us today? Well, here's a graph that I think journalists might be interested in. We went around the world, we looked at individual countries, and we asked, how does storm intensity, so when a country gets hit by a more intense storm, how does that translate into damage? And this is in part related to the overall resilience of the infrastructure in that country. And so what you see that I've flagged here is the United States, where we just got hit by many, many storms, and we've all seen what many of those consequences are. That's actually not too surprising, because the global pattern is that as countries get wealthier, they become increasingly protected. Their infrastructure becomes hardened, and they are less damaged by more intense storms. But the US is an anomaly, in part as a result of many government policies, so that we actually exhibit the same type of sensitivity that poor countries like India and China exhibit, and we are far behind countries of comparable income like Japan and Australia. This point became very pointed recently when Puerto Rico was hit directly by Hurricane Maria. And so this is actually a graph where I took the model I've been showing you and just applied it to Maria, because a colleague of mine just called me up and said, what do you think the overall economic impact is? So we ran it, and this is astounding, okay? So the intensity of this event is unprecedented in our data set of thousands of storm events in the Atlantic. The only events of comparable intensity to what just happened to Puerto Rico are events that have happened to much smaller countries, all in the Pacific Ocean, where storms are historically much more intense. One way to think about this is it is possible that the Atlantic is the new Pacific. So when we take our previous numbers and we ask what might happen to Puerto Rico, you can look, for example, at what historical economic growth in Puerto Rico has been. So since the economic crisis, there has been some steady recovery. You can sort of extrapolate what that might look like, just drawing a simple line, using the historical growth rate. But based on our numbers, when Hurricane Maria struck just now, over the course of 12 hours, we think they may have undone roughly 26 years of economic development. Okay? There are few things on the planet besides nuclear weapons that destroy value as quickly as hurricanes. Now, these numbers have been received by policymakers, and they are now being used to think about how to adjust financial policies and the reconstruction of Puerto Rico, which is quite useful. And one thing that we've been sort of pushing with folks to understand is that these storms, the effects that they have, are comparable to other things that we pay a lot of attention to, things like financial crises or the recession. The overall economic effects of these climatic events are quite similar in magnitude. All right, so I want to switch gears and ask what happens to societies when they sustain these large economic shocks driven by changes in the climate. And so we've done a lot of research on it, and one question you can ask is whether this can actually be a destabilizing force in a political or institutional sense. So we can look back in time, and what I'm showing you here is a graph of how, from the paleoclimate literature, of how wet a region in the Fertile Crescent was historically. And what you see is an orange bar, which is the period in which the Akkadian Empire collapsed. And it happens to line up with a massive drying event in the same region. Okay? So this was a previous finding by another team of researchers. And what my colleagues and I did is we went throughout the literature and we collected the different records. And what you see are similar systematic patterns, whether or not it's the collapse of the Mayan Empire, the breakdown of Angkor Wat, the transition of dynasties in China, or the rise of golden ages and recessions in medieval Europe. There are many, many historical strong associations between institutional collapse in these different societies and long-term, gradual, or abrupt climatic events. Now, you can look at this and think, okay, well, this is just deep history. This is going back, obviously, several thousands of years just on this graph. But a point we like to make is that at the time that many of these societies suffered these types of collapses, their purchasing power in real terms, the best that we can estimate it, are actually comparable to the economic purchasing power of many societies around the world today. So it's a little sad to recognize even just that fact, but at the time that the Mayan Empire collapsed, the estimated income per capita is not that far off from what the current income per capita is in the Central African Republic today. Similarly, the last dynastic transition in China, households had incomes that were probably comparable to what we see in Afghanistan or Haiti today. Okay? So I think we don't want to say that this is exactly what we're planning on seeing, but we should be cautious in simply dismissing it. Now, thinking about different types of questions about what might cause these transitions, we actually sort of landed in this psychology literature of people exploring how violence and aggression might actually respond to changes in the environment. And so there are many psychology studies in laboratory environments that have asked this question. So for example, in one that is a very famous study now and actually quite entertaining, there was an experiment where two folks went out to this parking lot, to the housing development, sorry, and there was a single road with a single light. And what they did during every single Saturday during the summer in Phoenix was one of them would drive a car to the light while it was red. They would wait for another car to come up behind them. The light would change, it would be green, and they would just stay. For the 12-second light cycle, they wouldn't move, and the whole experiment was just simply how long did the second guy in the car behind them lay on the horn, okay? And they did this for every Saturday in Phoenix, and the result is the graph on the right. You see that people's willingness to display aggression towards a complete stranger was responding directly to the temperature on the day of the experiment, okay? With people acting more violently and aggressively towards strangers as things became hotter, okay? In what is a less entertaining, perhaps more serious experiment, they took some Dutch rookie police officers, put them in a training simulator where they're approached in the simulator by an individual holding a crowbar, and they have to decide how to respond. And what the experimenters were observed is that when they increased the temperature in that room, the rookie officers were more likely to adopt an aggressive posture or to draw and fire their weapon in response to the exact same simulation. So these types of studies make us think that there's something sort of very profound and serious about how people's minds interpret and react to other individuals' actions as a function of the environment. And in fact, one of my students recently completed a paper. Patrick Bayless did some really interesting work where he examined what was happening on Twitter as a function of the temperature where individual people all across the country were tweeting. And so he examines a whole bunch of different measures. The one that's, I think, the simplest to explain is just the presence of profane language. And so you see that when an individual person on Twitter is at a hotter location, the probability that they're swearing on Twitter is much higher, okay? They also use fewer smiley faces. So these are sort of detailed micro-level studies, but one question we asked is what happens when the entire global climate shifts abruptly? Do we see any effects on the stability of societies around the world? So in one study, we looked at the El Nino Southern Oscillation, which is essentially a flip-flopping of the top layer of the ocean in the Pacific, which leads to profound climatic changes around the globe. So when an El Nino event occurs, what you observe is a large amount of warming in the Pacific, in the equatorial Pacific off the coast of South America. That releases a huge amount of thermal energy into the atmosphere that then propagates around the tropics as an equatorial Kelvin wave, leading to heating and drying everywhere in the tropics, essentially, for up to a calendar year. And then after the event ends, we see subsidence and conditions return to usual. So what we did is we tried to identify those populations around the world that were impacted by this large atmospheric wave every time the Pacific Ocean flipped over like this. And so that's the large red region you see through the tropics. We call that the teleconnected region because their climates are sort of connected to what's happening in the Pacific. Then what we asked is what is the probability that any one of these countries in this tropical band starts a new civil war on any given year? And what we see is that as the global climate shifts from conditions which are relatively cool and wet in the tropics, something known as La Nina, towards the conditions that are hotter and drier during these El Nino events, we see that the rate that new civil wars are generated throughout the region essentially doubles from 3% per year to 6% per year. Now, one thing you can ask is whether or not there's something going on just in the global economy or politics that's correlated with El Nino and might be driving this result spuriously. So as a test, we looked at those countries that were too far north and too far south to be hit by this large atmospheric wave. And we looked at their data sort of like a placebo test. What we see is in those countries, there's essentially no coupling to the global atmosphere. There are conflicts. You have regions like the Balkans and Central Asia. But they essentially generate conflicts at about 2% per year, and it's unrelated to the state of the global atmosphere. Now, this is one study, and then what I'm showing on the right are those regions around the world in green that we were identifying as affected, and the relationship I just showed you is the bottom panel. And we looked around the world to ask whether or not this relationship was generalizable. So you can look across countries in Africa in a different study we found. You can look across pixels just in East Africa. And then within individual pixels, there have been studies of individual villages. And we looked and reanalyzed the data from all of these studies. And what we see is that around the world and throughout history, there are systematic associations with hotter and drier conditions generating higher rates of violence at all different scales of social organization. This result is pretty replicable around the world. So for example, here you see political violence in some regions of Kenya responding to temperature. We see land invasions increase in the Brazilian Amazon in response to changes in the rainfall patterns, as well as interethnic riots in India doing the same. And even here in the United States, one of the most astounding patterns is how tightly coupled violent crime is to temperature on the day the crime is committed. Okay? So on the bottom two panels, you see rates of violent personal crime across the US, or in the middle panel, sexual assault in the United States increases essentially linearly and stably across, throughout the last 40 years around the country. The lowest right panel is actually data from every single at-bat in Major League Baseball, where you see that the probability that so what happens in baseball is that sometimes the pitcher gets hit, the pitcher hits the batter with the ball, maybe by mistake, right? And then the teams switch, and often the other team's pitcher will then retaliate by intentionally hitting the other team's batter, okay? So in the lower right-hand panel, what you see is the probability of that type of extremely violent retaliation as a function of the temperature on the day of the game, okay? And so this helps us understand and realize that there might even, that those psychological mechanisms I was pointing out to you in the beginning that sounded almost amusing might actually lead to escalation in intergroup violence. And in fact, I think an interesting story about that in particular is even Shakespeare was aware of this, okay? So I don't know who here remembers, but the very first scene in Romeo and Juliet is Mercutio and Benvolio standing around debating whether or not they should go to the bar. And one of them says, "Today is so hot, we definitely shouldn't go because we will definitely get in a fight if we do." And then they go to the bar, they get in the fight, and that's what the entire book is about. In a more serious situation, we are now studying different types of violence, including intrapersonal violence. Okay, so this is actually a very recent and important study by my graduate student, Tama Carlton, that just came out over the summer. And what she pointed out is that we observe using these methods that at the same time that crop yields throughout India collapse, you see on the right-hand panel as the daily temperatures get very hot, crops die off, and we see the rate at which suicides increase in these locations to increase dramatically. And there has been epidemic farmer suicide throughout India and huge amounts of debate about what is driving it. So this is helping us understand that perhaps it's due to crop failure throughout these regions. And as a placebo test, you can ask what happens to temperatures during the non-growing season. And we see that there's essentially no relationship either to crop failure or to suicides throughout the country. Now this is important in part because the climate is already warming. We now have roughly 30 years of warming that started in 1980. And so Tama went and computed the number of suicides in individual districts in India that could actually be attributed to the warming that we've already experienced to date. And so by her estimate, roughly 60,000 suicides since 1980 would likely not have occurred had the warming not occurred. So the last thing I want to talk about is overall economic productivity. A lot of the things I've told you about suggest that economics are in some way at the core of the changes that we observe. And we've known for a while that the environment, for example, the temperature, has a big impact on people's ability to do work. So this is one of my favorite studies in which Charles Mackworth in the 40s took British soldiers and had them do arm curls in a laboratory until exhaustion, right? And he pointed out that as the temperature got higher and higher in the laboratory, they were able to do less and less work. This is perhaps not surprising to many of us. What we see is that this is happening even in the modern economy. Okay, so on the left, for example, you see an example in which one of my colleagues showed that changes in crop yields across US counties decline precipitously once temperatures get up to a high enough point. And on the right, we see workers across the United States work less, do less work, basically supply less labor in relationship to the daily temperature. What we've done in the recent study that was mentioned is we've taken all of these different studies and we've developed projections about how they translate into changes in future economic activity or economic impacts across the United States. So I showed you there was this very strong linear relationship between temperature and violent crime. That's the top two panels. And I showed you that there were changes in labor supply that sort of just tail off when things get really hot. And so both of these examples have impacts that look approximately linear. So as things get warmer across the country, we see that different counties everywhere experience these impacts in a fairly uniform way because everyone basically just shifts to the right a little bit. However, there are other types of impacts that we call nonlinear impacts, where changes in temperature might lead initially to a decline. So for example, when we look at mortality, we see that cold days are dangerous to individuals. People get sick, die of different types of pulmonary infections following cold days. They also die in response to hot days. The safest temperatures are those in the middle. And so what happens is that when you warm up the country, some people who start out on the left side of that graph are actually coming down the slope, and they're actually getting safer. Whereas other people who are in hotter locations are on the right side of the graph, and they're going up to the right as things warm up. The result of that are the maps on the right-hand side, where you see large amounts of what is essentially redistribution. Those locations in the country that start out hot end up being the losers, and those locations in the country that start out cooler end up being the winners, because warming benefits them by improving their safety in the top panel, or in the bottom panel on the right by reducing their overall demand for electric services. We've then done this for a whole bunch of different sectors, trying to compute who loses what at different points in time in the future, looking at agriculture, crime, health, coastal damages from storms, labor supply, and then we add them up, looking at different changes in global mean temperature. So each climate simulation on the left is a little set of dots, and we simply just draw a line through those dots. That black line, that's a curve that relates overall economic damage in the country to changes in global mean temperature on the horizontal axis. And you can see what's making up that curve, different components of the economy on the right. And one of the things you see is that human health is one of the most valuable things in the economy. That's that big blue wedge. And so that drives a large fraction of the overall economic burden in our calculations. When we add it all up and we ask who are the overall net winners and losers, we get this map, which displays a median scenario of business as usual near the end of the century. What you see are that the locations throughout the South and the Midwest, places that tend to be fairly poor, that have lower incomes today, are the biggest losers, and that there are even some locations that are net winners in the northern parts of the country. On the right, we've reorganized the data to rank individual counties based on what their income is today in comparison to what their projected economic losses are. And what you see is an increase in inequality because the low-income communities are suffering the largest relative to the higher-income communities. This is what I've described in the past as potentially the largest transfer of wealth that may ever occur in the United States. Based on new results that are not quite public, but this seems like the right community to be aware of them, we estimate that the overall losses due to changes in temperature to the US economy amount to, in net present value, which is what we should be willing to pay for them today, at roughly a 3% discount rate, are, in the central case, roughly $6.5 trillion. Now, this relationship, this nonlinear relationship that I'm talking about in overall productivity, actually manifests not just in US counties, but around the world. So on the right is what we see if we look at US counties, we look at their overall productivity in relationship to temperature. On the left is what happens if we look at entire countries in a macroeconomic sense in response to changes in the overall country's temperature. So what we've done is we take that graph on the left and we simulate what happens to countries around the world as the planet gets hotter. And you see a very similar pattern for the exact same reasoning that I showed you before. Countries that were originally hot decline faster. Countries that started out cool actually can benefit from in a macroeconomic sense from warming up a little. So the colors on the top panel show you what happens to future income in a growth projection in a warming world. So you see cool places on the bottom left, cool places like Europe actually benefit because their overall growth trajectory will accelerate. North America is kind of a wash because we have cold regions and warm regions, and when you add those two effects up, it ends up mostly just creating a very uncertain future. But then you go to the tropics and the hot places around the world, and you see invariably very scary looking graphs, frankly, like from an economic standpoint. That graph on the lower right is the trajectory of South Asia in a simulation in which you just slow down the growth rate by 1.5 percentage points or so, okay? Integrated over a century, this can lead to huge changes in inequality at a planetary scale, far above and beyond what we see in the world today. So on the right, you see our estimate for what happens to the richest 40% of the world's population if people stay where they are, as well as the poorest 60% of the world's economic perspective going out to the end of the century. Now, it turns out that if you add these things up, there are a lot of poor people. They have less assets, but overall, world income is projected to decline to the tune of roughly 23% by the end of the century in the central case. The other thing you notice about the graph on the left is that there's a big fan of possible outcomes. One of the implications of a changing climate is that it increases uncertainty in what lies ahead, because it is actually quite difficult to make economic projections, even with huge amounts of data. And so having that type of uncertainty in our future itself is, you could say, emotionally taxing. People don't like uncertainty, and that's why we have insurance markets, so people can try to increase their uncertainty. But what is very difficult at a planetary scale is to find someone to insure you. So we've taken all these results and we combine them to try and paint a picture that people can understand about what the world might look like. So here on the left, we have a business as usual scenario where I've taken all the different climate models and I've colored the world based on the changes in temperature that are forecast. On the right, we have a scenario in which we invest very heavily in mitigation efforts. That's RCP 2.5, and you see that the colors don't change so much. And what I've done is I've overlaid on top of that the night lights, as seen from space, of the human economies that are relying on the climate. And those night lights have actually been rescaled in the left panel to reflect the change in economic activity in the simulation I just showed you. So you see that the tropics, even the southern parts of the United States, Central America, all of Africa, become much darker relative to this world where we have sustained economic growth. So you can look at the graph on the left, and you can see that, and you can say things look bleak. I'm going to curl up, go home, get a glass of wine, be depressed. But what I would tell you is that you should be hopeful. This is the first time in human history when we have the technology to actually see ahead at what might be coming down the road. In the past, those societies that confronted massive environmental change, their leaders had to rely on fortune tellers, rolling the dice, looking at the stars to try and make their decisions. But today we have science, we have data, we have analytics that allow us to see what's coming more clearly so that we can have an open dialogue and collectively make informed decisions about the type of world we want to live in and leave to our children. Thank you very much.
I want personally to thank Dr. Solomon for the very clear presentation. What I most I admired the most is the examples you give to make your talk simple and to make everyone understand. Before opening the floor for question, I just need to tell any media representative who need to do a one-to-one interview with Dr. Solomon to come up after we close, and we have a room in the 5th floor in the Marriott, so for interviews, so we can do it. Now we can open the floor for questions. Okay, there is a microphone in the middle, so you can. Yeah.
I think you told a really clear story here.
Excuse me, can you introduce yourself?
Okay, I'm Cindy. I'm coming from the scientist aspect and learning about the writing aspect. And I think you told a very clear story with your data showing, okay, this is linked to this. And you showed a lot of different examples of rising temperatures. How hard was it to, isolate that it was temperatures, or did you know going in, okay, we're looking at climate change, so obviously we look at temperatures, but do you look at other factors, and how do you clean that up?
So in the beginning I described sort of the heuristic quasi-experimental approach that we take, and that is very important. So one thing we never do in our analysis is actually just, okay, so I'll back up a second. What people did historically, so Montesquieu wrote a book in which he looked at the world and he said, many of the places that tend to be poor also tend to be hot. And so based on that observation, he postulated that, well, temperature sort of makes people lazy, and that's why South Korea is poor and North Korea is rich. That actually is what he wrote in his book. And so that is what we call like a cross-sectional comparison methodologically, which means you look at different locations at one moment in time and you attribute their differences to maybe one factor that you think is important. As an experimentalist, that's a terrible thing to do because there are many things that make North and South Korea different from one another besides temperature, right? So we don't actually do that. That's why we pointed out in the beginning, what we do is we follow populations over time. So for example, we might look at a village in the Philippines and we look at it before and after a storm hits it. And so by doing that, we're essentially looking at the same population of people who haven't really changed themselves, like who they are, but their behavior changes. The assets they own change in response to the change in the environment that occurred abruptly, the storm that hit them. And so everything I showed you used that sort of general approach of trying to net out all of those political, geographic, historical factors that make societies very, very different and in fact uncomparable to one another in that cross-sectional sense. It's a really important question.
Hello, my name is Annie. So you did a lot of research in a lot of different areas. You looked at the effects of storms and then maybe like, high temperatures on farming, and you put it all together. So what do you hope to accomplish with this set of research? Like what do you, if you bring this to the government, do you want, how do you prioritize, what's most important?
That really depends on who you're talking to. So a lot of our work has been used in decision making already. The military is very aware of the work relating to conflict. The work on Puerto Rico has been used in thinking about recovery during the storms. The GAO just published a report articulating, based on the work that I showed you for the United States, how the US should plan ahead and think about the financial implications of climate change for the US government from a managerial standpoint. So different aspects of our society or different aspects of the policymaking process rely on different things, whether you think about law enforcement or economic growth. And so I think we try very carefully to tailor the useful information to the decision makers to whom it's most relevant, while at the same time helping people realize that sometimes there might be other factors they haven't been focusing on. So for stability, for political stability, you also need economic stability. And I mean, some people are very aware of that, others less so, and so we try to get everyone on the same page.
Hi, Lee Cooper from PNAS. I was wondering, you had the one graph that looked at how solid economies are compared to basically how much they're affected by hurricanes. And the USA was up in the corner. And you mentioned that there was a reason why we were there was maybe lots of reasons why we were not on the general trend line. Can you go into those?
So the overall explanation, I think, is still up for debate. And I have a few graduate students looking at that question. We have many national policies that essentially subsidize risk-taking, that encourage people to behave in ways that an economist might not think of as the right allocation of risk. So, it is appropriate for some people to want to live on the beach where things are might have a higher likelihood of being destroyed by a storm. That's okay. People can make that decision. But it's important that those decisions are connected to other types of economic trade-offs. So one thing that is a famous issue is the National Flood Insurance Program essentially lays out subsidies in a way that are sort of disconnected from the actual geophysical risk of suffering a flood, or in particular a hurricane. And so what that does is it sort of, in an economic sense, it subsidizes people living in riskier places than they would have had they actually faced the true price of that risk. So that's just one example. There are others, and sometimes it comes down to simply not investing heavily enough and steadily enough in some of our infrastructure as well. And that we know is like a national conversation right now. So I'm not the first to raise that point. So there are actually, we think, many factors that contribute.
Hi, I'm Kathleen Wong with the UC Natural Reserve System. I was curious to know whether you ever factor in the value of losses in ecosystem services in your research?
We certainly want to. It is very hard. Well, there's two ways to view it. One is that everything I've pointed to in some sense is a natural service, that the atmosphere provides basically cooling capacity. You could think of it in that sense. But it's not always relying on the biological systems, which is, I think, what you're asking. We have explored the idea of how can we account for changes in ecosystems. Part of the challenge there is that it is fundamentally very difficult for people to use these types of methods to measure the overall economic value provided by ecosystems. It doesn't mean they don't provide it. It just means from sort of this rigorous data-driven perspective, it's very hard to capture. And so we are actively working on that. But at present, we don't have really clear evidence, or even, I couldn't even tell you order of magnitude what those type of numbers look like.
Hey, I'm Annalee Newitz. I'm a science journalist. So I love the interdisciplinary reach of your work. I mean, you're dealing with history and economics and environmental science and archaeology, and there's probably more that I could name. And I'm curious, when you're presenting your work or when you're dealing with people in these different disciplines, where do you get the most pushback and skepticism? Like, is it from environmental scientists? Is it from economists saying like, no, this can't be true? Like, where are you getting your biggest pushback?
To my face?
To your face, or in comments on your work, or in snotty footnotes, whatever.
I definitely get the most pushback from other academics. I think some of the things, like the idea that we get grumpy when it's really hot, it's fairly intuitive. I think there's a resistance in some communities to believe that those factors matter in a substantive way for political stability. And that's an open question. That's actually, it's not, to be honest, when I was a graduate student working on the El Nino study, my advisor, Mark Kane, was like, you know what, I kept saying, well, it's either the economics or the taxation system declines, and Mark kept saying, I just get grumpy when it's hot. I think that's part of what it is. And I was like, no, it can't be that. And more, when we look at the data, the patterns actually look increasingly like that. So, I mean, even I sometimes am skeptical of those things. So we've definitely gotten some pushback in some parts of economics or political science. where there is not as much study of the natural system and there's a lot of focus on human decision making as being a primary thing that sort of steers the ship. And that's part of why we make those comparisons in the thinking about the economic growth implications of a hurricane, pointing out that leadership transitions or financial crises have similar order of magnitude impact, because we want people to understand it's not that those things don't matter, it's that the environment also matters, and that in fact, if apples to apples sense, they're not super different in order of magnitude. It's just we as a species are genetically programmed to be fascinated by each other. And so we have like tabloids. We follow other individuals a lot and their decisions, and we spend a lot of time paying attention to them. And all of us are much less aware of like how the temperature of this room might be affecting our cognitive function. And so it's just, we're not built to register all these things, I think, the same way we are built to focus on social interaction.
Hi, I'm Tom Levinson. I'm a science writer and I teach at MIT. Greatly valued your talk, but my uneasiness is that what you are saying so thoroughly conforms to my, beliefs, inadequate knowledge, and expectations. I mean, I'm primed to accept the argument you're making. And of course, economic modeling is a fraught and difficult field, and its recent history is littered with enormous errors and a variety of different arenas and so forth. So I guess my question is, how do you stress test your own work? And if you were really pressed at the bar, off the record, with no one else in the room after the third drink, how confident are you of, say, the middle case that you kept pointing out to us on the graphs?
First, I'll say the writing department at MIT is great. That's where I learned to write.
Thank you.
So pointing out the middle cases of the graphs, I often do simply because it's a number we can discuss. But I think it is very important to emphasize the spread, and that there's a huge amount of uncertainty in many of these things. We exert a huge amount of time and effort trying to capture that uncertainty so as not to over focus on just that central estimate. So what I sort of didn't say is that our estimate is that the US economy might suffer somewhere, $6.5 trillion due to warming, plus or minus about $4 trillion. So there's, then it's in the paper for sure. We spent a lot of time thinking about it. It's important to emphasize. But I think, many of the things I've shown you, we've come at the problem from many different ways. And in some parts of our work, actually, we have intentional firewalls where we don't let data or methods from one approach contaminate data and methods from another approach. And the theory there is that hopefully one day the two methods will converge in the numbers that they report, and at that point we will be much more confident that they're telling a complete story. So we do a variety of things, 'cause we understand that science is a process, and that right now I can tell you the facts that we do know, and there's many things that will become clearer with time. But we spend a lot of effort continuing to investigate each of these things, looking for, I showed you many cases of replication from other studies, and that's really been important. And a lot of the results I showed you today have already been replicated in numerous contexts by follow-on research at other universities or as parts of the government, the IMF. And so it's through the standard scientific process of hypothesis, test, replication that we are gradually gaining confidence, I think.
Yeah, thank you.
Hello, my name is Jennifer Lima, and I'm with UC Santa Cruz Science Communication. So in the wake of Maria, we see the private sector companies like Tesla investing in Puerto Rico. Have you reached out to the private sector? Do you see any investment from them? Have they reached out to you, or do you see any interest in opportunities for them?
For the most part, we're not involved in that particular process. Some policymakers have reached out to us, and we've helped provide them with relevant numbers, and we're doing some additional investigation for them to help them think about what might be coming ahead. But not like the private sector folks rebuilding. We have not been engaged with any of them.
Hi, Alan Brown, Mechanical Engineering Magazine. I wanted to pick up something that Mr. Levinson said. He noted that economic models have failed quite a bit recently. And of course, one of the reasons that they failed is because the underlying market, the structure of the underlying markets were changing in ways that people modeling the markets weren't picking up. So they didn't see certain types of linkages between debt globally. Obviously, something as large as climate change is going to really change the fundamental structure of markets. So how do you try to get your arms around that?
You're identifying some really important issues that are very pervasive in this field of research. So, for example, if the climate changes, people are going to develop new technologies to try and cope with those changes. And it's very, very difficult from the perspective of us where we stand today to guess exactly what's going to work and what's not going to work. Many of the numbers I showed you were actually shown relative to a baseline. And so one way of dealing with some of the things that we can't foresee is to be a little bit more modest in what the claim itself actually is. So we often will tell you, I can tell you how much productivity might be distorted relative to some baseline, but I can't tell you actually what that baseline is, because I can't tell you how much innovation is coming down the road. And so that's one. The other thing that I think you're raising is that the overall deviation from the baseline that I'm trying to capture could itself be fundamentally threatened by changes to the structure of the economy. And some of that is just something we'll have to accept in some cases. There's always going to be a limit. But in many cases, we're developing new methods and techniques to try and think through how things like adaptation, reallocation in the economy. So we think crops will be grown in different places in the future. We think, my office in Berkeley might get air conditioning one day. Like those types of changes will be down the road and they will cause adjustment. And so a lot of the research frontier right now is thinking through how trade networks are going to be restructured. How is economic activity going to shift? Where are the populations going to move? So that's actually thinking through those fundamental structural changes is really where the frontier is right now.
Hi, my name is Gabe. I'm a writer in DC. So you're telling us that maybe the U.S. is looking at $6.7 trillion in losses due to climate change, but right now our government is run by people who don't even believe climate change exists or are unsure if it exists. I mean, do you feel like you've been able to have any impact on the sort of climate deniers who are in leadership, or is that not an audience that you've been able to impact so far?
So, administrations come and go. So, there are different people who have different views, and I think we are trying to educate the broader scientific community about what is down the road. And I think some people are very receptive, especially in cases when they can see changes that they understand and that impact their daily life, or if you help them translate the changes into something they care about, like their paycheck or rates of crime in their community. So we've found that there are some people who, even if they are a little bit skeptical about, they're not sure how much they trust the climate scientists per se, once they understand that if there's some chance that it's a little bit like Pascal's wager, right? Like if there's some chance that those guys are right, this is the impact that it will have on our bank accounts. I think there are some people on the margin who are interested, who become a little bit more interested in learning more. We've also found we've had a lot of engagement with folks who tend to view themselves as very concerned about economic numbers, people who think about investing, who tend not to think about the environment as much. People on Wall Street, for example. When you talk to them about, we have a very close friend who works on Wall Street and is a bit skeptical about some of the environmentalist arguments that they often hear in the media. And they were out here visiting, and we were talking, she was asking about my work, and at first she was like, oh, well, like climate change is not something we need to worry about. And I said, okay, well, we're not sure how much we want to worry about it. We want to think about it like an investment problem. Like we want to allocate some of our resources towards managing that problem. Not everything. We don't want to be too shrill about it. We don't want to over-allocate because the fire department needs to stay open. But we do also want to know, like, what does the downside risk look like? And put in those terms, suddenly she was very engaged. She understood what I was talking about. That is portfolio management in just the classic sense. And so it has definitely engaged those communities that are normally just checked out because they are not so interested in hiking in the woods, you know, the way many other people might find those things more valuable.
Hi, I'm Nadia. I'm a writer from Malaysia. I'm just wondering if your studies have looked into climate change refugee issues and just the transboundary nature of the problem and how will it affect the neighboring countries which are also in the developing region. Thank you.
We have looked some at the movement of populations in response to climate change. It is really hard. So we actually have a lot of resources allocated towards cracking that problem right now. One reason it's not so obvious what happens, in part because there's sort of two things that happen when the environment changes. People lose a lot of assets. In some cases, large populations do get up and move in response to better economic opportunities elsewhere. So in the United States, for example, we saw what happened during the Dust Bowl. Huge populations moved from the collapsing economies in the Midwest towards the coasts, flooding the labor markets there. On the other hand, there are cases in which people start losing access to resources so much so that they become trapped and they can't get out because they don't have the resources to make the leap to the other communities. So it's not obvious which one occurs, and it ultimately relies on a lot more research, but doing migration-based research is fundamentally really hard because it requires tracking people. And so usually once people get up and leave, you don't know where they are anymore. And so you don't necessarily know what happens. And so working with that type of data is just like a really hard problem. And so there are many research teams around the world looking at it right now. And I think we've done some back of the envelope calculations, and the thing that's like a couple steps ahead that I don't think everyone realizes, some of this is published, these back of envelope calculations, but if populations really do get up and move in a big way, the population concentration in the places where they ends up going up a lot. Because there are really large swaths of the tropics that can be heavily and very adversely affected. You can have a large number of people ending up in the tropical margins where population densities really could go up in I think, quite concerning ways. And those receiving locations might have concerns about political stability and what resources are required to support receiving that kind of community. As we've seen even in the US politics today, dealing with refugees is very controversial because it does take some toll on public resources.
This will be the last question.
Hi, I'm Kathy. I'm a science writer. I just was not sure, the 6.7 trillion, was that just for temperature increases as opposed to including hurricanes and coastal flooding and wildfires and all the other ways that you might be measuring economic impact? And if you can measure all those, are they additive? Are they overlapping? Are you doing that?
So that number in particular, just to clarify, that was only the effects of temperature on economic productivity. So that was not even accounting for the health impacts of mortality that I was showing you that are not necessarily captured by the overall market. And so part of the exercises we've been doing is as we enumerate these different types of impacts, starting to collect them, taking the information about the hurricanes, taking the non-market impacts to health, taking the overall market impacts in terms of productivity, and adding them up. And so some of our research is actually trying to go through that exercise as well. But that particular number is just the effect of temperature on market productivity in the United States.
I want to thank Dr. Cheung for the interesting and informative presentation and clear answers. And I want to thank you all for being with us. And as I told you, Dr. Solomon is still around. So if anyone needs to do an interview or anything, we are here. Thank you. We have to clear the room now for another. Thank you, Doctor.